As we go on to our next section, special products now, but we're still multiplying. And here we're going to introduce the FOIL. Now, I'm assuming many of you know the FOIL already. The F, let me see if I can color code this here. The F stands for the first terms. The O stands for the outer terms. The I stands for the middle terms. And the L stands for the last terms. Now notice there are two little lines under each one, so that indicates everything is covered. So foiling is just a way to do it, and a very useful way, and they want you eventually to be able to do it mentally. So let's do the first. That would be x times x, which gives you x squared. Now, when we do the outers, we get x times 4, and that's a plus 4x. When we do the inners, get a negative 3 times x gives us a negative 3x. And when we do our last, we get a negative 3 times a positive 4 gives us a negative 12. Now notice, as we did it traditionally, this times this and this times this, we had something very similar, but now we've done it sort of mentally, and we've written our answers. Often we do this part mentally. These are like terms, so our final answer now will be x squared plus x, because there's a 1 there which we don't write, minus 12. Now, in doing the FOIL, and we're going to use this a lot in this chapter and in next chapter, which is in the next course, eventually we're going to take this trinomial and factor it into its factors. So this is a product of multiplying two binomials. So we often say we're going to undo the FOIL. Now in these next two examples, remember we're going to do it by FOIL, and I'm not going to be showing you every little step like we did before, but when we multiply our first terms, we sometimes just go like that. That gives us a 5x squared. Now when we do our outers, we sometimes go like that, and we know they're going to be like terms, so we can put them like this, a negative 10x, and our inners, a negative 7x, and then now our last, a positive 14. So again, we're calling on skills you may already have, and we're going to blow on the embers to lighten the flame. So this will then become 5x squared. We do this mentally, sort of, and that's a negative 17x plus 14. In example 3, we want to do the FOIL first, and then we'll multiply everything by 2. So our first is a 2y squared. Now my outers are a negative 1y, inners a positive 12, and I can do that mentally. That leaves me with a positive 11y minus my last here, 6. And again, this is still in parentheses because I'd have to now multiply it by 2. So I just distribute the 2. That'll be 4y squared plus 22y minus 12. Now later, when we go to factor these, we'll see that we have a common 2 in each of these terms. So we'll factor that 2 out, and then we'll factor this into these. But that comes later. Remember, the multiplying part is easier. Now, keep in mind that we call this section special products. So we had this before where we just repeated it twice, and we could FOIL, or we could use the special way of multiplying a binomial that will be squared. And the rule is square this first term. Multiply these two terms together. That gives you 1 times this is 3y. Now times it by 2. So it'd be 3y times 2, double it, is a plus 6y. And then square the 1. Now this special product of squaring a binomial in this fashion gives you what we call a perfect square trinomial. Now, this is a perfect square trinomial. As we do all of these as examples, these will all be perfect square trinomials down there. So, the key is when you see you have a perfect square trinomial, it will factor later into a binomial square. But right now it's just practice. So let's do it. Square this, multiply that, double it, square that. A perfect square trinomial. Now notice the middle signs are different here, so this comes out a little differently. This is still p squared. Multiply that is a negative pq, double it. There we get a negative, and then n term q squared. Square it. Multiply these together, that gives you 10x. Double it, that gives you the 20x. And here we're squaring that. That gives us x to the 4th. Multiplying these, that gives us a negative 7x squared y. Double it. And square the last term. Now again, it's through practice that you master this. Some things, and again, these are all perfect square trinomials, where the n terms are perfect squares, and the middle term, if you take the square root of 4(2) and you double it, you get the middle term. And notice that if the sign in the binomial is negative, then the middle term will be negative. Here it's positive, here it's negative. So these are special products, squaring a binomial into a perfect square trinomial. Now a little introductory lesson here as we do the product of sum and differences of the same terms. So these are the same terms. One's the sum, one's the difference, and it's the product that we're multiplying. Now another name for these where we have a plus and a minus, the same terms. These are called conjugates. Now, when you multiply conjugates, it's the same as this. The product will be something special. So let's do it, FOIL it. This is going to be a squared. My outers are a negative ab. My inners are a positive ab. And my last is a negative b squared. Now notice something very interesting happens here. My middle terms cancel out through addition. And we're left with a squared minus b squared. That is the difference of perfect squares. Again, this is an example of a special product. When we multiply conjugates, we get the difference of perfect squares. Now, when we factor the difference of perfect squares, they factor into their conjugates. So we're looking ahead here a little bit. Okay, now I modified A little bit. They had a 4 stuck in there, and later you would just have to multiply by 4. But I wanted you to show these conjugates. So remember, there's no middle term, so we're just multiplying these. X squared minus 16. And then we would multiply it by the 4, and that would be 4x squared minus 64. But this would be 36t squared minus 49. And this one here would be x squared minus 1 over 16. And this would be 4, I'm running out of ink here. Let's change color. 4 p squared minus q squared. And this would be 9x to the 4th minus 25 y squared. Wow. Again, as you recognize these are now perfect squares. The difference of perfect squares, they would factor into their conjugates. Now, doing this last example, what they're doing is giving us a variety of things. Here, this would be the traditional FOIL. First, 3x squared. Now, my outers is a positive 4x. Inners, a negative 15x. Add them up mentally. And then your last gives you this. Here's the special products of a binomial that's squared. Square the first term. Multiply these together, you get a 28x, double it, 56x. Notice middle sign is positive. Square the last term. Here, these are conjugates, so we're just going to get y times y squared, and this is a negative 0.36, the difference of perfect squares. Now in letter D, this one was a little tricky, but just do it. This times this will be 3 y to the 6th. So that's not too bad. Now when you do your outers, it's just a negative 1/5 times y to the 4th. Notice here we don't get like terms. Tried to save you from a sneeze there. I don't know if I did or not. But inners now, 2 times 3 is 6 over 5 y squared. So even though it looks maybe difficult, it's not too bad. And then they're not like terms, so you don't have to add them together. and just last now is 2 times 1 is 2, 5 times 5 is 5, and it's a negative. Now in this last example they give you, it's a trinomial by a binomial. And again, I'm strongly recommending that you do these vertically. So you end up with like term columns, and there's the answer. Well, okay, this finishes our special products. I've taught other courses where they've given much more difficult examples than these, but there's the methodology. You'll practice, do your quiz-me's, and we only have 2 topics left in this course.